Okay. All right. Hi, folks. Good afternoon to everybody. I think it's the sleepy time of the afternoon. Hopefully, we'll get a bit of a jolt with security. How many of you here doing something around security and Hadoop together? Okay. I see a good number of hands. The one polling question that I've stopped asking is how many of you have had security breaches? Because mostly I get an answer that it's 90% of the people have had breaches, the other 10% don't know about it, right? So this topic is very obviously timely. We've been hearing a lot about security incidents, breaches, high-profile cases, insider threats, all kinds of things. So I'll definitely do a bit of a background about what kind of security problems are out there, because they fall into certain categories. These are not random, unknown, patterns that are completely unrecognizable type of attacks. If you look at it, you really have patterns that you can get out of all of these attacks. So I'll do a quick overview of the kinds of attacks that have happened. This here is the title. If you're in the wrong presentation, this is your time. So here's what I'm going to cover. So we'll talk about what kinds of security problems are out there. We'll talk about why today's approaches are not meeting the needs of security challenges faced by enterprises, because we've had security products for a very long time. So we'll talk about that. Now, why is this a big data problem? It's not about just the volume at all. In fact, there's very little to do with just the volume of the data. But it is a big data problem, and we'll talk about that. We'll talk about the success of Hadoop and machine learning in other industries. There's no reason why we cannot apply the same concepts in security. And then we'll get into some descriptions of algorithms where we talk about different kinds or classes of algorithms that you can use for security purposes. A couple of examples really quickly, and then finish up the conversation with a call to action. What can you do with all of this? What can you do with your existing Hadoop infrastructures? So one more polling question, since more people have actually walked in. Again, how many of you using Hadoop for security today? Just another show of hands. So I think far fewer than I would have thought. So I think the bit of a background is good. So to begin with, security is a bit of a unique use case. There's a specific set of things around security that you have to be able to do. Most companies are at a point where they want to do incident analysis, or they only have the capability to do incident analysis. And what commonly known as IR or DBIR, data breach incident analysis. Incident analysis really is a reactive method, which you need, but you obviously need to do some things proactively so you don't have to repeat the same incident analysis over and over again. Anomaly detection is a big, important thing to consider. When you speak very broadly, anomaly detection almost can be meaningless, because what is really an anomaly unless you've defined the context around it? So it's very important for you to define the data sources, the personas in play, and the use cases that you're trying to defend against that will drive your anomaly detection methods. Otherwise, any old anomaly detection algorithm or method is just not going to work. So security, that's why I say, is a special use case, because the context behind things that you derive from your analytics is going to be essentially the way you solve the problem. Queries at scale, you need to be able to perform queries. And these may be related to incident analysis. These may be related to more proactive things you want to do. Predetermined metrics. Like you, some of you may be more in the BI world. So just like in the BI world where you have KPIs, key performance indicators, in the security world you have metrics. And these metrics are important for you to define beforehand and have an idea, because that is what helps you measure the quality of your security preparedness. If you don't have the metric, you don't know what you're defending against. And this has nothing to do with machine learning algorithms or an analysis. This is really just computing real time or in a batch mode from your Hadoop infrastructure. But knowing these metrics is key to driving your business. In this case, your business is security preparedness. These are all topics we will cover. So, we don't have to go into a lot of detail here, but I took some examples particularly because they all have a different method or vector of attack and for a different purpose. Target, obviously, everybody's aware of that. My credit card was one of those. I got a replacement. And here, what happened was the HVAC vendor was able to, who had access to some parts of Target's infrastructure, was able to move, as we call it, laterally within the network and get to POS system that they shouldn't have had access to. Now, that sort of thing is impossible for you to be cognizant of just using manual incident analysis or manual viewing of events. That's the sort of thing that an algorithm needs to catch. Why is something moving laterally in my network? Is something only an algorithm and real-time analytics can catch? You can never write a rule for it. The NSA thing was completely different. That was an insider attack. Now, granted, you have things at the perimeter. You're trying to catch things from coming in. What do you do with an insider attack? How do you know which one of your employees is going to do something? I was talking to a good friend of mine who's CIO at a networking company, and one of the use cases he said he would love for us to address is, during the 2 weeks that somebody serves notice, he wants to be able to know what they did. And it's impossible to physically watch all of their activities. You have to have certain algorithms in place that catch anomalous behavior during that time. That was the Snowden case. And this was even more amplified because you can have privileged account administrator type profiles, which could be doing something malicious. Now, either their accounts could be taken over, and therefore the malicious activity, or they could be a malicious insider. Either way, it's the behavior that is going to determine whether or not it's a security alert. It's not anything static. It's not a rule that you can write. And so on and so forth. The point being, security is a top CIO concern. Another CIO that we're talking to recently said to me, there are only 2 evergreen spending areas in his budget, and it's common across most CIOs. One is storage, and the other is security. You would never walk into an environment where they say, well, thanks, I'm all set, I'm as secure as I can be. No one will ever say that. Now, it's a top concern too, and it's in this analysis, in this survey, you can see it's closely tied into the big data problem as well. So attackers, and this is a famous annual, and I see some Verizon folks here in the audience too, annual data breach and investigations report. Highly recommended for any of you who's very security oriented to read it. It's a good number of pages with a lot of data on breach activities for the year. And this clearly states how the attackers are way ahead of the defenders. And I'm going to jump into exactly why that is. And one more market data slide I'll skip through. So why is it today that the attackers are way ahead of the defenders? That's because we are all looking at technologies that have been around for 10 plus years. If you think about how most technologies today work, whether it's antivirus or firewalls, they all have some kind of a signature based on which they detect security issues. So they have a known signature database. They look for patterns. They look for objects. That is not going to work. It's not going to continue to work. It's going to catch some things, but some things are still going to come into the network. And this doesn't address the insider threat problem at all. So signatures have a limited use case in today's complex, sophisticated attack environment. Rules, this is another way people program alerts for themselves. So rules are static, right? By definition, you write a rule saying anytime I see more than 50 failed login attempts at this on this server, alert me. Now that is really not indicative of something happening that is malicious. Even before you hit that 50 threshold, you could have been attacked. So rules only go so far, and they always they address something that you've already experienced in the past that you've converted to a rule now. It doesn't address any new malicious behavior. Malware detection methods like antivirus and object sandboxing and things like that, they are also limited because they look for objects. And essentially what they do is they sandbox the object elsewhere, explode the object, look for all patterns of behavior coming out of that object, and then report back saying, that's a good object, you can use it, or it's a bad object. Again, objects have become more sophisticated too. They know when they're being sandboxed. They don't really, like an advanced APT would never exhibit all of its capabilities until it's actually in the network. And these activities can be pretty dormant, and then act up. That's what the APT really does, and then go dormant again. And we're not talking hours and days. It can last weeks and months. So we really today, 80–90% of security spend that is happening in these areas. This is all 10 plus years old. Nothing has changed in this world. The firewalls of the world are pretty much the same. The SIM products of the world are pretty much the same. There are newer companies, but they kind of borrow the same old methodologies of 10 years ago. So what we really need, given Hadoop is mainstream, is think out of the box here and leverage Hadoop just as you would in the advertising world, as you would in the e-commerce world, in the payments world. You have to use it extensively for security. So why is this a big data problem? We talked about why there is a close correlation between the next step we have to take in security and big data. Because today, there's a lot available that we can leverage. Hadoop was not where, today it is not where it was 5 years ago. With a variety of security events coming in, it's just impossible to parse all of this data, make sense out of it, and start correlating it. You have to have a pretty hands-off ETL approach. The kinds of data sources that come in, they could be AD, they could be DNS, DHCP, or web server, proxy server. There's a variety of sources. It could even be just net flow coming from your network, packet captures. It's a lot of data. You really can't put it into a traditional system and parse through all of this, perform all the ETL, derive correlations. That's what Hadoop is made for. So it is a big data problem for that reason. The second thing is the sophistication of analysis. Like I said before, it's not about having simple rules and simple things that you observe. It's not about the metrics. It's about complex analysis that you have to do over, and this goes into the third bullet, over a long context of time. It can be months, like I said, in the case of APTs, which are advanced persistent threats. These have a tendency to do something malicious, go dormant for weeks or months at a time, and do something malicious again. So the level of sophistication of the behavior here is not something that we can humanly catch. It has to be algorithmically caught. These can be sequences of activities. They can be non-linear sequences, completely non-contiguous. So it's very complicated, the level of analysis, the variety of data that comes in the context of time. So you pretty much need a big repository on Hadoop, algorithms running on top of it, and that's what's going to lead us to closing the gap between the attackers and the defenders. So the right tools for the right purpose. So much as I said that today's technologies are pretty old, they all serve a purpose. So I wouldn't come in and say your Hadoop repository now displaces all of these guys. That's not the point at all. The point is they are still missing a level of sophistication that they are not able to catch with the approaches they have. You still want the firewall, you want to protect the perimeter, but if you think closely, in most environments, the perimeter, what really is a perimeter anymore, there are mobile users, you're using SaaS services, the perimeters are vanishing. So the concept of a firewall must evolve. Same thing with the shadow IT products, the whole problem with SaaS. Data leakage is happening anywhere, mobile devices, cloud services. Finally, SIM products, which are incident analysis, are very reactive. So you really need a new paradigm. So I think it's a bit more, it's a bit of an eye chart, so I won't spend too much time on it. There's too much going on here. Essentially, there's a copy of these slides that's available. You may want to take a look at this later. What it's saying is the level of sophistication of attacks over time has gone up significantly, and we really haven't kept up. So what we need to be aware of is, I have a more in-depth slide on this coming up. If you broadly break down how a security breach happens, it happens in these 5 stages, very broadly. The first is essentially the attacker has to do a bit of research, exactly as to what the attack plan is going to be. It's going to be penetration and then lateral movement across. Most of our time and money is currently spent in stage 2, protecting against infiltration. Like I said, that's the firewall approach, guarding the perimeter. But for a minute, let's admit that this essentially has not blocked any of the threat examples that I showed you before, the security breach as a target. All of these guys have firewalls and all of that. Yet if we continue to spend all of our time and money on the infiltration stage, we are leaving the bulk of the attack in the other stages, capturing the data, exfiltrating the data, the selling of it in the marketplace. All of these have certain behavior patterns that we can catch. And this is the algorithmic approach that can catch all of this. So for a minute, let's all assume through the rest of the session that you've already been infiltrated. We are not here to protect your network from being infiltrated anymore. You're already breached. Now what? You don't just give up. There's ways for you to go catch these other stages through behavior. And this is where algorithms come in. Now, I think at the end of the day, this is a debate, but I think everything is statistical. You can call it machine learning. You can further subdivide it and say there's another category of statistical models. They're all statistical. The subtle difference is the machine learning stuff is meant to be programmed to be self-learning. So input feeds back into itself to make it a finer tuned model. This was one of the harder courses I did in my master's around neural networks, the whole concept of it being self-learning, right? And that's what the machine learning world is all about. And I've heard people talk about machine learning algorithms separately from statistical. I will make that distinction as well for the purposes of being clearer. But I think at the end of the day, everything starts from being statistical, and then it grows into either being self-learning or just purely a mathematical model. Both are important. And I'm going to talk about a set of algorithms. We're not going to go deeply into any of these. But you have to be cognizant of what kind of algorithms exist and what you need when. So think about time series for a minute. When you think about breaches or even operational issues that you have in your environment, time is pretty much the most important component of your analysis. If you don't have the concept of a timestamp, you really can't get much. And everything is timestamped, fortunately. So time series analysis, which is a very mathematical and statistical approach, is something fundamental that you have to have. And you can do this in real time. There are complex event processing engines, and there are other things in the open source ecosystem that you can use for these regression type models. This is very important. This immediately gives you value because you can look for events, you can do event analysis, you can do quick event correlations, and give you those security metrics you were looking for instantly. This is all real time. Next, you come down to classification models. Here, you really want to classify. You have various entities. You really want to group them together. You can do a variety of things here. K nearest neighbors, for instance. Take any entity, take a user, for instance, and start taking a look at all the connections the user has with other users, with applications, with devices, with other entities, whatever your entities are. And you could have hundreds or thousands of entities. You can create these relationships. Now, the purpose of this is to classify and group things together, because if you start looking at individuals in all their glory with all of their events, you'll never find patterns. You really have to start grouping them together and start linking them. So you essentially bring down, it's like a funnel of a billion events down to a few manageable groups of events that you can get something out of. So these algorithms are extreme, and different algorithms suit different needs, and it's not often a one-to-one correlation between your use case and the algorithm. It could be a few algorithms that drive your use case. So you can almost never just say, I'm going to do one of each and be done. It's a fine-tuning model. The third set of algorithms you want to be aware of are more on the clustering side. This is where you really get into similarities and who's looking like whom, and watch for telltale signs. For example, if somebody in sales is behaving like somebody in engineering, there's something wrong. Either their ACLs are wrong or they're doing something malicious. This is where you start defining clusters that are both visually impactful as well as can drive you results. K-means is a very common approach, where K is the number of clusters you want to get out of a given data set. So a given data set, which can have billions of entities and events inside of it, can be grouped into K clusters. And you can choose how tightly they need to be linked and not. It's tunable. The fourth set or the category is something around inference. This is where we get into predictive analytics. And this is important because you not only want to get a sense for what is in the data, you want to know what to do now and what to expect in the future. So this, if I draw the analogy of, let's say, something more famous in the e-commerce world called the market basket analysis. How many of you know what market basket analysis is? It's a common, yeah, so it's a good number, but I'll tell you really quickly for the others. What it is, it's simply the concept of knowing the buying pattern of a buyer. So if I put a couple of things in my shopping cart, knowing what else I might buy, right? Same concept in security is being able to infer that this confluence of events is going to lead to this event. So that helps you be more proactively prepared for the future. So that's what is called predictive analytics. So inference model-based algorithms help you predict, so you can be more proactively prepared. And then finally, simplification models. This is where you have to fine-tune and drop a lot of noise. And that's important because, like I said, you could have hundreds or even thousands of entities. You can have users, applications, web apps versus database-driven apps. You can have any number of entities, mobile devices, et cetera. At some point, they're not all the same, right? So you have to assign the right weight to the right things that lead to the most value. So these set of algorithms help you do that. This is ranking based. So you can drop a lot of your entities out of the equation. So you can fine tune the model to just give you the most important entities and the most important insights or value you can derive out of those entities. This is important because you have to trim down any problem. If you have a big problem, you're going to have to cut it down. And the way to cut it down is not randomly, but using algorithms that help you shed the ones that have the most amount of noise and keep the ones that have the best relationships amongst them and offer the highest amount of value. Now, these are the set of algorithms that we've used, others have used, and I think have been applied really well in other industries. And I have a slide coming later on other industries' success. And there's no reason why these would not apply to security. And that's where we have to go. This is what has been lacking. Wasn't possible 10 years ago, wasn't possible 5 years ago, but now everything in Hadoop is so much more mainstream that we can do a lot of this today. So having said this, it's not sufficient to be aware of just the algorithms and try all of these. You have to know what kind of input data is coming in, because the insights are only as good as the input data. And so we'll talk a bit about what kind of input data needs to come in. So this is an attempt at categorizing some of the input data. So if you go from the bottom up, the bottom of the pyramid is your network data. Let's just call it layers 1 through 4. Now, there's a lot of data there. The problem with this approach, well, first of all, let me describe what data we are talking about. We're talking about network packet data, NetFlow, packet captures, taps. This is pretty much your level 1 through level 4 in the OSI layer. And the problem here is there's a lot of data. And it's not the storage of the data, it's just the context between a user and an application and the navigation is kind of very complex and buried and sometimes missing in this kind of data. It's a lot of data, but the context is not easy or clean. As you move up the chain, you go up to the application layer 7 type HTTP type traffic, application traffic. This is where you get a lot of context. So back to my earlier point, it's not sufficient to have the right set of algorithms. You have to have the right data flowing into the algorithms that have the relationship, that have the context. So keep in mind that the pyramid goes like this. You can collect a lot of data, but with little signal to noise. And you can collect some little data with a lot more signal to noise, and you got to combine them. The answer never lies in just one part of the pyramid or the other. The key is to have the right balance, depending on what it is that you want to do. Do you want user-level analysis of what's going on? Or do you want object-like application or device level? Depending on that, and depending on how deep you want to go into the transactions to tell if there's a security problem or not, you have to have the right input data. There's a bit more detail on this as well. This is more on the kill chain. So ideal Hadoop-based solution. Very simply put, you want everything in a Hadoop landing zone, data lake. People call it different things. Essentially, the reason being, if you already have a Hadoop repository, you can run these algorithms in data science on top of that, and the visualization beyond that. But if you don't, I think it's time to definitely, at least experimentally, put a Hadoop cluster together, feed some data into it. We'll talk more about what kind of data you might want to start with. put some data into it, run some algorithms on it. You may or may not have data science skills, but that would be ideal. There are products that are starting to emerge in this space that you can use. You don't have to build your own Hadoop repository. You don't have to do the whole thing, but that's the ideal. This is what the world should be moving towards. This is what is the next gen security platform. This is what is going to help bridge the gap between the attackers and the defenders. Now, I said, this we did in my previous company, which was acquired by VMware and now part of Pivotal. We did a big data analytics platform, and we saw a lot of use cases in different industries. And at that point, one of the more applicable industries was e-commerce. And machine learning and Hadoop have gone a long way in this industry. This was one of the pioneering industries in terms of learning user or buyer buying habits. Now, if it can be done to understand an e-commerce user and what he or she likes and what they do and what they will likely buy next, it is equally applicable in the security world within the enterprise to know what a user normally does, what time they log in, what are they going to do next. The same concept, it can be done. And the parallel here again in the ad tech industry, where we've seen a lot of money being made and a lot of success too, frankly, is knowing who the visitor to a website is, when they will come next, what ad do I place. These are all done in milliseconds, right? I mean, the SLA here is extremely tight. For security, you don't really have to be that stringent. It doesn't have to be done right then. Even if you know the same day or the next day that something happened, you can go block it. But today what's happening is for weeks and months, you don't know that Snowden was leaking documents or the Target breach was happening. It all happens later when you hit that fifth stage of the kill chain, which is when the data is in the marketplace. That's when somebody says, hey, this happened. Then you go back 6 months in time and start investigating. These industries took on a higher bar. They said, in milliseconds, I want to know what ad to place in front of my customer. What retail product should I be putting in front of them right now? If you apply the same thing in security with a lot less stringency, I think we can do a lot more. And that's really where we need to go. And that's what is going to bridge the gap again. So type of attacks, I think most of you who are in the security field would already know this. And I won't read what's on the slides here, but I'll kind of summarize it saying, attacks have different purposes. One can just be a debilitating type of attack, like a DDoS, saying, hey, I can take you down, right? That's something that you can never predict, but you can clearly see a pattern coming in. If you just had a visual in front of you that said, traffic is starting to pour in, I wish there was something like that, you can prevent a DDoS attack. So that's one debilitating type of attack. It's seemingly meaningless, but it happens. The other is theft, right? It can be intellectual property theft, which can be done by an insider, or it can be credit card type financial theft, which can be done by an outsider or an insider. Those are the kinds of breaches. And then finally, there is the APT class, which is mostly corporate or state-sponsored espionage, which has taken on such alarming dimensions, obviously, lately, that we need to significantly change the way we deal with it. It's no longer the same old firewall approach. We are all dealt with IP theft. How are we going to protect our enterprises from IP being exfiltrated, right? Are we suited? Do we have the right thing in place for protecting against that? So those are the kinds of attacks. They have changed. The world has changed significantly from just being hacked to being very, very well-sponsored attacks. So we need to up the ante, so to speak. So I said I'd talk a bit more about data sources. I showed you the pyramid, which is the layers 1 through 7, and how more data at the top can give you more context and less in the bottom. Now, if you want to dig a level deeper, now you can look at your Active Directory, single sign-on, type. You can even just start there and say, all I'm going to do is take a look at all of my Active Directory events over the last 60 days and do some analysis on it, or my one login or single sign-on, whatever it is that you use, and do a lot of analysis just on that one data source. And you'll be surprised at how much insights you can get from just that. Now consider correlating that with a bunch of other things that exist in your environment. So the thing here is you have this data. You already have this data. The correlations have yet to be made. The context has yet to be established, and a single place to persist all of this doesn't exist. That's what is needed, really. All of the data is there. It's sitting in Windows event logs. It's sitting in domain controller logs. It's all sitting there. We need to put it all together, run some analyses, and do some correlations. And above all, have those metrics in your heads so you can say, here's what I'm looking for. I'm looking for all kinds of malicious user behavior, which means more than 3 failed logins here, or repeated attempts to go to multiple servers. And I have some examples of that coming too. These are the kinds of things we need to be putting together. May not have time for this one. If I do, I'll come back here. It's simply an anatomy of an attack. The summary of this is how you can really progress from just knowing a few basic details to doing analysis at each step, saying, where's my traffic coming from, right? So you have a lot of traffic coming in. You isolate a couple. There are third-party feeds that currently tell you where bad IP addresses are, what the bad URLs are, what bad objects there are. Simple correlation will tell you of all the traffic coming in, you have 2 or 3 IPs that are bad, and you want to isolate the users associated with those IP addresses. Who are the users who are communicating with these bad IP addresses? Now, they could either be malicious or this could be inadvertent usage, right? Either way. Then you go down from stage 3 to 4 saying, okay, here are the 2 users who are constantly communicating with known bad IP addresses. This is all easy to do. And then you go down, and now you figure out for those 2 users, what are all the things that they are doing? Which applications are they accessing? Which file services are they addressing? And what's the timeline of all of this? So with just this simple analysis, given 1 day's worth of data, you could do this analysis step by step and isolate it down to a couple of incidents that you might track your security breaches to. Doable. I'll skip this. So here's some examples that I mentioned. There's something, people use different terms. These are just some examples, by the way. Ground speed violation, very simple concept. If you are showing as having logged in from your corporate office here in Santa Clara or San Jose, and then within a minute the same login appears in London, that's what is classically called a ground speed violation. The same user, within the span of a minute or 2 or an hour even, cannot physically be in 2 different locations. But again, it's obvious, it sounds very logical, but this is not the kind of thing that without a learning system, an algorithmic approach, you will ever catch, because you're not going to be sitting there watching for every single login, checking the geo of one login versus another. Never going to happen. But if you have an algorithmic approach where you've looked for these anomalies, where you can analyze it programmatically, that's what is going to help you, kind of do a leapfrog and say, well, I can now, in my environment, address land speed or ground speed violations. Same thing with lateral movement. Telltale signs. This is what exactly happened at Target. The HVAC vendor who only has access to some peripheral HVAC control systems was able to move parallelly. And that's a very classic form of attack where you're able to penetrate in one place and spread the attack until you hit a point where you've gotten enough information to exfiltrate. And that's exactly what happened at Target. It's called lateral movement, where the infiltrator is able to go look for vulnerabilities across the network and is able to move. And as they move, what they're doing is they're doing essentially a directory listing. They find things that are looking attractive. People have weird or very indicative file names like financials.xls. They look for things like that. They extract that data. So it's called lateral movement. They're essentially progressing through your entire network, doing directory listings and finding things they want to exfiltrate and taking it out. The third type is domain name creations, and I myself came across this very recently, where I learned, where a lot of SOCs, security operations centers, where they have analysts who are trained to look at dashboards and look at data and events flowing and catch anomalies. They fail to see things that are, just impossible to catch by the human eye. Things like a root account that instead of having an O, 2 O's has an O and a 0 or 2 zeros, or an admin account instead of an I having a number 1. These are things that kind of fake you out. And again, unless it's programmatic, cannot be caught. It's very hard. This is back to the privileged account abuse, where you think something's a root account and therefore it's making all of these accesses, but it's really not a root account. It's not your standard root account. It's not your standard admin account. So these are the kinds of things that are fairly common. Attack patterns are, fairly common. But the point is, with this kind of a movement, a shift to Hadoop as a repository with the kind of simple algorithms, without needing data science folks, you're able to get a lot of value addressing these kinds of things. But as new patterns evolve too, if your anomaly detection techniques are advanced enough, you can catch the newer things. What if you didn't know there was such a thing as a ground speed violation? That's the kind of thing you can also catch with this algorithmic approach. So I think we are down to the last couple of minutes, and I'm down to my last slide as well. Where do you start? And this is where we started from. This is where our company started from. A massive data lake is clearly important. So the concept of Hadoop is very, very mainstream, putting everything into a data lake. And often, you already have a data lake. People are doing something with data going in. Key is to know what kind of data is going in. Is Active Directory data going in? Is some other kind of DHCP or domain controller data going in? This is important. So having that repository, a data lake, is important. Now, like I said before at the start of my talk, the problem here is not just one of scale. It's the fact that it's impossible for you to do ETL on all of these different data sources. You just need a place for it to go reside, where you can do correlations across seemingly disparate types of data. The correlations could simply be user ID and timestamps, but that's the sort of thing you don't want to mess around with and build ETLs and put it into a data warehouse and have people write SQL. That just won't scale. So you really need this massive repository. Analytics, like I said earlier as well, the only reason I split it out is just easier to comprehend. There's machine learning, which are self-learning algorithms, some of the classes that I described, and statistical approaches, just purely mathematical. You want to sometimes just see the mean number of logins per day or failed logins per day. These are telltale metrics that if you just had some real-time metrics being displayed to you coming out of a complex event processing engine, that'll go a long way to help you solve the problem. And finally, the actions. Now it's up to you. We can automate actions. You can take actions on your own. But that's important. And this is where it ties back to somewhat of a predictive strategy too. You want some inference-based algorithms. So you want to know if a confluence of certain things is happening right now, what else is going to happen? That's something very important. That's for you to be proactive. I wouldn't even advise it on day one. I think day one, it's important for you to have this repository and a simple way to compute all of these real-time metrics. That's the first step. The second step is to have some basic algorithms that give you some intelligence into what is going on. At least looking at some clusters of users and clusters of application activity will go a long way. And then finally, you can get to be more predictive. I wouldn't even start thinking about predictive right now. With that said, that's all I had. I think I have a minute and a half left and would be happy to take any questions if I can answer them. Yes?
Thank you. Given the context of security, why would I want to use a data reduction technique like DCA, singular value decomposition, when the problem that I might be looking for in ancient objects that I
That's a fair question. So I'll repeat the question. So if you remember the algorithm slide that I had, one of the last ones there was a way to kind of trim the problem down from a signal to noise standpoint. The question is, why would I want to do that? Or I would even extend that question further. How do I do that, right? So I don't think there's a magical answer. The reason I think you want to do that is you want to contain the number of dimensions that are important. Now, how do you determine what is important? I think has a certain amount of learning and analysis, so your models get better over time. The reason we've seen is you have hundreds of entities that can potentially cloud. This is where I said anomaly detection is only as good as knowing which entities and activities do you want to create the anomaly detection around. If you have too many, you have too many anomalies. And you just have to trim the problem down with some basic analysis that tell you everything that deals with the user is important. Everything that has to do with the mobile device is important. Everything to do with my SaaS not important, or whatever it is. That way you trim the problem down, your anomalies get a lot sharper. I've had conversations with folks who pushed back against general purpose anomaly detection for good reason. I think that's the reason why you want to do it. Now, how well it it becomes. And if you're worried about dropping the wrong dimensions, that's a fair problem. I think that needs to kind of fine-tune itself over time. Yes?
You made a lot of different points. What kind of tools do you use to analyze logs?
Yes, so there's a variety of tools. Splunk is not particularly good with the Hadoop backend. I think they have something. But there's products. I mean, we had a product before which we sold to VMware as well. You can use any BI product that exists today. I think it's less about the analytic tool. I think I'm putting the onus more on the algorithms to tell you what's going on versus a way for the analyst to tell what's going on, because the latter is very human-oriented. And that's what exists today. SIM products, incident analysis tools, that's what they do. Whether they run on Hadoop or not, different question. But if they, let's assume they all did, and they have the massive scale behind them, which they don't, but that's the first problem. Let's say they solve that problem. It still relies on the human. And I think we need to elevate, and there's value for that in the SOC, right? But I think why they are not catching, Target has a huge SOC, right? Why they are not catching something like this is because they don't have those, the capabilities to automatically surface up 10 things that are looking weird that you would have never caught as a human analyst, even with rules, I think. But back to your question, I think there are tools out there. I mean, any one of the ones you mentioned, but I think the problem is less that and more of not enough intelligence pushing up insights to this level that I can then act on. So the goal is I want to spend more time solving than trying to find, because I'm still failing at finding as a human. With that said, down to 0, but I'll be happy to step off the stage and take any questions.